You are currently standing on a planet that follows strict rules. Gravity pulls you down, your blood stays liquid, and the stars stay where they belong. But if you travel just 7 miles down or 5 astronomical units out, the rules of reality simply stop working. We have discovered a 40% error in the universe's mass, a creature that thinks with its skin, and a planet that is literally screaming. Today, we are going to the edge of what is possible to see what happens when the fundamental laws of physics reach their breaking point. For decades, these were just anomalies on a datasheet, buried in the journals of specialized researchers. But using new three-dimensional maps of the cosmic web and the first ever direct images of interstellar visitors, we can finally piece together the story of what we call the universe's skeleton. It is a story that suggests our peaceful, predictable corner of the cosmos is not the rule, but a very rare exception. Let us begin with the budget. Astronomers have always had a ledger for the universe. By measuring the light from the early universe, they know exactly how much visible, ordinary matter should exist. We call this baryonic matter. It includes every star, every planet, and every grain of dust across the entire cosmos. The total weight is roughly 100 sextillion kilograms. That is a 10, followed by 53 zeros. The problem is that when we actually look for it, the math does not add up. Since the 1970s, when researchers like Vera Rubin noticed galaxies were spinning far too fast for their visible mass, we knew we were missing something. But we are not just talking about the mysterious dark matter. We are talking about the stuff we should be able to see. For nearly 50 years, 40% of the universe's visible matter was simply gone. It was like looking at a finished building and realizing that nearly half of the bricks were invisible. Scientists have spent a lifetime hunting this ghost matter. They used our most sensitive detectors and deepest surveys, finding nothing but empty cosmic deserts. That changed in June of 2025. A team at the Leiden Observatory finally spotted it hiding in plain sight. It was not in the galaxies themselves, but in the long, thin filaments that connect them. They managed to map a single gaseous filament in the Shapley supercluster that stretches 23 million light years. To put that in perspective, that is the equivalent of 230 Milky Way galaxies laid end to end. This filament is part of the cosmic web, a skeletal structure of hot, low-density gas reaching temperatures of 10 million degrees Celsius. This web is the backbone of reality, the invisible scaffolding that dictates where every galaxy is born and where it must stay. But the breakdown of rules is not just a cosmic phenomenon. It is happening right here on Earth, 7 miles beneath the surface of the Pacific Ocean. When you descend into the Mariana Trench, you aren't just entering deep water. You are entering a space where the fundamental physics of biology are rewritten. At the bottom, the pressure exceeds 16,000 pounds per square inch. It is a difficult number to visualize, so imagine the entire weight of a full-grown African elephant concentrated on the tip of your thumb. Now, apply that force to every single square inch of your body. At this depth, the very molecules of life behave differently. The calcium that builds our bones and the shells of surface creatures would literally dissolve into the water. The proteins that power your metabolism would be squeezed out of shape. Under these conditions, life as we define it should be impossible. Yet, when Jacques Piccard and Don Walsh reached the bottom in 1960, they saw a flat, living creature swimming calmly past their window. We now know that creatures like the Mariana snailfish have evolved to survive by abandoning the standard blueprint. Their bodies are almost entirely gelatinous, using flexible cartilaginous bones that bend instead of shattering. They have essentially traded structural rigidity for survival in a world designed to crush anything solid. Even more unsettling is the intelligence we found lurking in the shallower depths. The octopus is a being that has survived for more than 500 million years, and it challenges every foundation of vertebrate biology. We think of intelligence as a centralized process, a brain and a head making decisions for the body. But the octopus is a distributed mind. 2/3 of its neurons reside in its arms. Each arm is an autonomous thinking entity. A severed octopus arm can still respond to touch, explore its environment, and even recoil from danger for up to an hour after being detached. But the real stress test for reality is how they manage their own genetic code. While most life is trapped by the slow pace of DNA evolution, octopuses can edit their own RNA in real time. They can change their biological response to temperature or pressure on the fly. They are essentially biological hackers, rewriting their own software to survive in environments that would kill a human in seconds. If we look further out, toward the gas giants, the chaos only intensifies. For centuries, we viewed Saturn as a peaceful jewel, but the Cassini mission revealed a violent colossus. At its north pole, there is a feature that defies fluid dynamics, a perfect, six-sided hexagon hurricane wide enough to swallow 4 Earths. Nature rarely makes straight lines. Yet this geometric scar has been raging for decades, perhaps centuries. Even the sounds of the planet are wrong. When we converted Saturn's radio emissions into audio, we didn't hear a hum, we heard a scream. And the rings we admire are not solid bands of gold. They are a planetary graveyard. The prevailing theory is that Saturn's gravity once grabbed a moon as large as Titan and literally ripped the crust from the core. The rings are the scattered guts of a dead world, a chaotic blizzard of ice and rock orbiting at thousands of kilometers per hour. This brings us to the most recent challenge to our model of the solar system, the visitor known as 3I Atlas. This object did not form in our neighborhood. It came from the void between stars, traveling at 58 kilometers per second. It is the fastest object we have ever detected in our solar system, moving on a hyperbolic trajectory that ensures it will never return. Everything about 3I Atlas is an outlier. Its alignment was almost perfectly side-on with the plane of our planets, a T-bone collision that is a massive cosmic coincidence. But the most confusing detail is its light. Most objects in space have a positive polarization, meaning light bounces off them in a predictable way. 3I Atlas has the most extreme negative polarization ever discovered. This suggests a physical composition unlike anything we have ever seen in our own sun's backyard. It forces us to ask, if the rules of chemistry and light are different in the star system where Atlas was born, how many other versions of reality are out there? We are now seeing a modern race to answer that question. China, NASA, and private billionaires are no longer just exploring for the sake of wonder. They are racing to the Mariana Trench and to interstellar space because these broken places contain the resources and the strategic leverage that will define the next century. In the trench, we are finding trillions of metallic nodules that could power the green energy revolution. In space, we are mapping the cosmic web to understand the very origin of time. But there is a gap in how we view these discoveries. We tend to look at the missing mass of the universe, the biology of the abyss, and the geometry of Saturn as separate mysteries. But what if they are all connected? What if we are looking at a single geometric blueprint, the cosmic web, the tectonic subduction of the Earth's crust, and the neural network of an octopus are all universal stress tests? They are the moments where complexity becomes so high that the standard rules must break and reorganize into something new. For most of human history, we believed we lived in a world of static, unbreakable laws. But the more we look into the dark, the more we realize that our peaceful environment is a fragile pocket of stability. We are not the standard model of the universe. We are the exception.